In this question, we are given two particles that move along the x-axis, and for one of those particles, particle P, we have the position of the particle, the function that shows the position, and for another particle, we have the function for the velocity of that particle, and the initial position at time t equals 0. So the first question is to find time intervals between 0 and 8 when particle P is moving to the left. And so this is the time when, or time interval during which the velocity of that particle is negative. So it's moving in this direction to the left. So let's find the velocity. Velocity of particle at time t is just the derivative with respect to t of the position of the particle. And so the derivative is log of derivative of log is 1 over, so it's t squared minus 2t plus 10 times the derivative of the expression within the log, which is 2t minus 2. And so we need to find when this Vp of t is less than 0. And that happens when this expression is a numerator or denominator, the product of those two or the division of those two is negative. And you can see the denominator is always positive because this is really t squared minus 2t plus 1 plus 9, which is t minus 1 squared plus 9. So this is always greater than 0. So the only component of this fraction that can be negative is the numerator, and so we need to find time when 2t minus 2 is less than 0, dividing by 2, t minus 1 is less than 0, or t less than 1. And so the answer then, the particle moves to the right for t between 0 and 1. So whenever time is greater than 1, the particle will be moving to the right. So this is our final answer. In this part of the question, we need to find all times t during which the two particles travel in the same direction, which means during which the velocity of both have the same sign. And so we just saw for particle P that V of P of t is such that if we show the interval from 0 to 8, that velocity is negative on the interval from 0 to 1, it's 0 at 1, and then it's positive on the interval from 1 to 8. Now let's look at the velocity of particle Q, what signs it has. And so velocity is given by this function t squared minus 8t plus 15. So let's factor this out. This is a quadratic equation which gives us t minus 3 and t minus 5. And so we need to find the intervals between 0 and 8 when this function, the signs of this function. So let's do this 0 to 8. Let's mark those 2 points, 3 and 5, and we can plug in the values. T greater between 5 and 8, let's say 6. This is positive, this is positive, so this is plus. Between 3 and 5, this is positive and this is negative, so this is minus, and then less than 3, both of those are negative, so the product is positive. So now we need to look at the interval, the combination of these two, when both have the same sign. And so we can see that that is between when t belongs to the following interval from 1 to 3 union 5 to 8 inclusive. And so this is one notation to write it. Another notation would be 1 less than t less than 3 and 5 less than t less than or equal to 8. So this is our final answer. During this time, both particles move to the right. In this question, we are being asked to find the acceleration of particle q at time t equals 2, and then whether the speed of the particle is increasing, decreasing, or neither at that time. And so let's first find the acceleration. A q of t is equal to, this is the derivative of the velocity with respect to time, so it's equal to 2t minus 8. And we can see when we plug in a u at time t equals 2, this is 4 minus 8, so it's negative 4, which is less than 0. And then the velocity of that function at time 2 is equal to, plugging in 2 here, we get 4 minus 16 plus 15, which is equal to 3, which is greater than 0. So we can see that the particle is moving to the right and that the acceleration is actually negative. So the speed is decreasing. So we can see that the speed is decreasing because the signs are different. And this is our final answer here. In this question, we are being asked to find the position of particle q at the first time it changes direction. And remember, from part B, we found that that first time is t equals 3. At that point, the particle was moving to the right before that, then it stopped and then started to move to the left. So we need to find the position at time 3. And so xq of 3 equals to the initial position of the particle plus the integral from 0 to 3 v of q of t v sub q of t dt. And so initial position is 5 plus integral from 0 to 3, plugging in the function, we get t squared minus 8t plus 15 dt. Integrating gives us 5 plus 1/3 t cubed minus 4t squared plus 15t evaluated at points 0 and 3. And so this is equal to 5 plus, plugging in 3 here will be 1/3 of 27, this is 9, minus 4 times 9, 36, plus 15 times 3, 45. Minus 0, because when we plug in 0 instead of t, this is 0. So overall, this is 36, 45 minus 36 is 9. 9 plus 9, 18, plus 5, 23. So the final answer is that the position of particle q the first time it changes direction, or at time t equals 3, is equal to 23. Thank you, and I will see you in the next question.